Hi there, my name is David Gardner, and this is my lab report on Lab 1 charge tape. So, the purpose of this lab was to observe the interactions between charged objects and determine how much excess charge these interactions caused on tape. To do this, we set one piece of tape on the ground and we placed another on top of it in order to charge the tape on top. From there, we were able to calculate the charge, and I found that charge to be 1.03 times 10 to the 8th coulombs. This number is also consistent with our model, and the amount of electrons lost were also pretty consistent, with 6.42 times 10 to the 10th electrons for our observation and 6.41 times 10 to the 10th electrons for our model. Now, two key physics concepts to know would be Newton's second law and Coulomb's law. Newton's second law helps us find the force of gravity on the tape, which we could then use to calculate charge by using Coulomb's law to connect force to charge. Um, so in this model here, we first had a U-tape, which we created by pressing it on top of another piece of tape. Um, we knew it was charged by holding our hand up against the tape, and we saw that it moved towards our hand. We then had to figure out which way our tape was charged, which we used by we had a pencil, we rubbed it in our hair, and we found that the tape was drawn towards that pen. So that meant that our tape was positive. It had a deficiency of electrons. From there, we made a second U-tape, and we placed one of the U-tapes on a bridge-like structure, and we would move the second U-tape in proximity to the original tape. And so we record this value as a displacement d, which was vertical and uh, had no horizontal influence. And so for this scenario, we recorded tape B as the system and the surroundings as tape A and everything else, since we are specifically looking at the displacement of B, and we will be looking at the force of gravity on B, as you can see here. We calculate the force of gravity by calculating the mass of our U-tape, which we assume every U-tape is the same, so we calculate mass times gravity to get the force of gravity, and there we set that equal to the Coulomb's law equation for an electric force, and we found that the since we knew both charges were the same, we could square them. We moved these variables to the other side of the equation. We found that to be 1.03 times 10 to the 8th coulombs, and we then divided that charge by the charge of an electron to find the amount of electrons lost, and to find the ratio of atoms to electrons, we found we used the surface area in terms of atoms of the tape, which we got by finding the normal surface area dividing by the size of the atom squared, and we found that to be 7.92 times 10 to the 6 atoms. So for our computational model, I decided to represent the tapes as point charges. The blue representing the tape A and the red representing tape B. You can see the electric field pointing down towards from B to A, and then you can see the force from A to B going up there, and we had very similar results to our calculations. I also defined a few functions here to make it easier for me to calculate things. So in terms of our final thoughts, um, some assumptions we had were we assumed that in our model we assumed that there was no air resistance um, because that would be difficult to calculate. We assumed that the tape would be treated like a point charge, as focused on a singular point, as you can see here, and we assumed that each U-tape had the same amount of charge distributed evenly. Now this was for our this assumption was for our observation, because when we were doing our displacement recordings, um, it would be a lot easier. And obviously there might be small differences, but they would be negligible. Um, so some sources of error we could have encountered were the excessive contact with tape, which would lead to reduced charge, some of the precision of our measurements as we use inches, and we had to convert to that, and the length of the tape. Now, if electrons had positive charge and protons had negative charge, we would be looking at a deficiency of electrons, and our tape would be charged negatively. And it's important to avoid touching the tape to minimize the charge loss from dispersion.